So morning around 10:30 we will be having the class on Sunday, the same time 10:30. Okay, so let's start with NumPy, guys. Yeah, online, can you hear me clearly? Great, thanks for confirmation, guys. So see, NumPy stands for, it is a numerical Python. The name itself says that num plus pi. So num will stands for numerical plus Python. This is what exactly the NumPy means, the numerical Python. So why we need this one is to perform the numerical and scientific calculations. Especially this is used to perform the numerical calculations. Numerical calculations. Okay. Now again, without NumPy can't we perform the numerical means? Yes, we can perform, but the problem is you have to do it everything on your own. Okay, you have to do it everything. Now for example, like if you want to deal with any of the formula, like if you want to do it like any formula, if you take square, if you want to do the square, or sum, how you'll do the sum? You will give it something like that using the sum function, right? What is this sum function? This is designed to perform the addition, right? In the same way, like there are the len is there. What is length will do? It will get the length of the elements in the sequential data type, right? So what is this? They are doing it. They are getting you all the things. Can't you do it on your own? Yes, we can do it. We can do it very easily. But the thing is that in order to avoid performing like every time manually by yourself, so what we are going to do it is, there is a built-in function, is called as length. So we will use this length to perform to get the elements, right? So in the same way, if you want to perform, okay, if you want to perform, like for example, I want to perform like cube of 3. How you'll do this? Right? Cube of 3. Now, cube 3 to the power of 5 means 5 times, right? This we can do it how? 3 double star 5. What does this mean? This is the similar to this. Why this is required? Then to cut it off the efforts. The same way, NumPy is a library. It is an open source library which helps us to perform the numerical calculations. So NumPy is, again, it's an open source and freeware. What is open source, guys? Huh? Source code is available. How it is written, that code is available with us. Okay, it is open to you. If you go and search it for the NumPy code in the GitHub, you are going to get it. Okay. Now the freeware means it is an 100% free, and this is the library of which one? Python library. Library which is used for numerical calculation. Okay, guys. Now, and the NumPy deals with like all the elements of the NumPy. NumPy especially deals with arrays. Okay, arrays. And now, what is the power of NumPy means actually? So, NumPy, why you have to learn means, if you want to say that, you can say that now the pandas is really very powerful. Okay, the pandas is really very powerful. The TensorFlow, have you heard about? Huh? No. TensorFlow. Okay, and the OpenCV. OpenCV. Clear? OpenCV. Now this is the pandas is a library which is used for data manipulation. TensorFlow guys. Huh? Now entire your deep learning is dependent on the TensorFlow. Complete deep learning. Without using the TensorFlow library, you can't perform the deep learning. Remember this. Complete. Now OpenCV is used for image processing. Image processing. Again, the thing is, all these three, yeah, let me take this gentleman's. Now, OpenCV, all these three are based on the Numpy guys. Without Numpy, you can't learn them. Okay, these three are based on completely derived from the Numpy. You can say that the Numpy is the parent of all these three libraries. Remember this. Now you deal with the images, and this deals with the arrays, right? Arrays means it is again a sequential type of holding the homogeneous data. Now this is now arrays, where arrays will store the numbers, but how come it is dealing with the images means all the image, each and every image, whatever you are going to deal with will be stored in the form of the pixels, and that pixels will be represented with the array format. Okay, so that is what is the power of the Numpy guys. Numpy, if you are learning it, you are indirectly learning the pandas. I mean, it's not completely pandas. The basic structure you will be learning it. TensorFlow, yes, it will be working, and OpenCV is also based on the Numpy only. Okay guys, so that is the actual power of the Numpy. See, coming down to the a quick history about the Numpy. He is the gentleman who built this Numpy library. Okay, now actually this Python was introduced in here. I'm going to explain you there. Yeah, 1991, right? It was an official one, it was a scripting language. When it was first released, it was a scripting language, guys. Now the people were started using Python, because it was free, 100% it was free and open source and very flexible. So they started using it in 1995. That means the first part of the 1994, the Java released. Java was released in the second part. So here, in 1995, the people wanted that. Before that, only 1992, 93, 94, the people were approaching the Guido van Rossum, the father of the Python. So for requesting for the special library for the numerical calculations. They were requesting for the special library for the numerical calculations. So the Guido has built up a special group called SGI. This is a special group of integration. This was specially used for developing the Numpy. Initially in this, there were two gentlemen were there. One is called as Jim Huguenin and Jim Felton. These two joined this group. These two people were in charge of this group. Okay, and then later on they've been supported by these people. That is again the David, Paul, and the Conrad. These were the five people where initially was designed a library specially for the sake of numerical calculations called as Numeric. They designed a library called as Numeric. There was some advantage about this Numeric. What is that is it can do the very fast calculations, numerical calculations. It can do very, very fast. So the major advantage was fast calculation of this Numeric, and this was released in 1995. Okay, this was released in 1995, and the advantage was very fast calculations. And the major disadvantage is, it was only restricted for the simple calculations. So disadvantage is it can do only simple calculations. It can perform simple calculations. Advantage is it is very fast in calculation, but disadvantage is it can perform only the simple calculation, guys. This is the major problem. Now, when it comes to the more complicated stuff, it can't perform. No, it can't perform. So in that case, again, the people were facing the problem of doing them manually. So then there was a second set of an upgraded version of this, NumPy was released, called as num array. They call it as num array, and this was released in the year like 1997. They say that 1997 they released it, this num array. Again, the people who are involved to develop is Perry, Todd and Rick. These are the people who were involved to develop this one. This is an extension of numeric. Now, this was good enough for the complex calculations. Okay, now it can do the simple calculations, and disadvantage, it can't perform the complex calculations. Okay, it can perform this. Is the disadvantage. Okay, now it can't perform the complex. Now, this was the advantage with this one is it can perform complex calculations. Okay, and the major it will perform the complex calculation with a good speed, a decent speed it can be performed. But the problem with this one was the same time it was taking for the simple calculations also. What the time it will take it for the complex calculations, the same amount of the time it was taking for the simple calculations also. So again, the people were a bit confused. This is very, very fast for the simple calculations, tremendously very fast it was. But when it came down to this one, so it can perform the complex calculations. It was rectifying the drawback of the numeric. But the problem is it was taking the same amount of time for the simple calculations. So the people who want to perform only the complex calculations, they have to go with the num array. If they want to perform the simple calculations, no, that is not the one. So in this case, so it was delay with the simple calculations. I was right. Disadvantage is it is slow performing. It is slow performing simple calculations. Compared to that of numeric. Okay, so this is where the people were loading using the two libraries. They were using the two libraries. When they want to perform the simple calculations, they were using the numeric. When they want to perform the complex calculations, they were using the num array. So there is a disadvantage over here. What is the disadvantage, guys? No, there is a disadvantage. Now we are having two of them. The customer is satisfied. The person who wanted to perform the simple calculation, they were going with numeric. The people who want to perform the complex, they are going with num array. Okay, but the person who want to perform both, so what he will do? He will do with the num array and numeric. There is a disadvantage over here. What is the disadvantage is, see, whenever you go with the upgraded version, like upgraded version, then your concentration will be more on the latest version, not on the previous version. Now, as I am developing a new version of my software, there was an old version of the software. Now I give a new version. New version will be good enough compared to that of old version in all the aspects. Now, when I want to go with the next version, from which one I will concentrate? New version I will concentrate and I will take it. But in this case, the customer has to, the developers has to concentrate on both. because some were using the numeric and some were using the num array. Okay, some were using the numeric, some were using the num array. So they have to give the upgrades for numerics as well as num array. So it was a dual rule over here. They have to do the dual upgradations. So to avoid this, then there is a gentleman called as this guy, that is Travis Oliphant. He came into the picture and he was a part of, in fact, he was his contribution was very small when he was dealing with the num array. Very small contribution. He knew the architecture of the num array. So this gentleman came up with altogether a new structure called as, and he called this one as NumPy. He called this one as NumPy. This is a combination of numeric and num array. It is a combination of numeric and num array. Now, this one was released in the year 2005. 2005. This is the year they released the NumPy. Now this is the final version of the NumPy, which was very comfortable with all the customers. It can perform the very fast, small calculations, and the complex calculations also it can perform it. And the advantage of this one is you have to load only one. Okay, only one NumPy, that's enough. Now this NumPy is, now as I told you, the NumPy deals with the arrays. Array means what? What is a list? What is list? I want the definition. I don't want this the data structure or sequential. I want the definition. What is list? Heterogeneous data types, multiple. It is used to hold multiple values of heterogeneous values. So it is an object which is used to store the multiple heterogeneous values. Okay, that is what is the list. Now the list is derived from the array. Remember this, list is derived from the array. Now what is an array? Array is also an object which holds the multiple values, but these values should be homogeneous. It should be homogeneous. Homogeneous means same data type. List means heterogeneous data type. Okay. Dave, give me the full answer. Fill the blanks. Okay. Now next, take it, guys. What is the array? Array is, it is an object which can store multiple homogeneous values, guys. This is called as an array. Okay, array. Now array is an heterogeneous which can hold the multiple homogeneous. What is the list? It will hold the heterogeneous values. Homogeneous means it will hold only one type of data. If it is int means it will hold all the ints. It will use the float means it will hold all the floats. String means all the string. Now this is the NumPy deals with arrays of n dimension. Arrays of n dimension. What is the dimension, guys? Okay, dimension means direction. Okay, in the direction. So if you take it like it's the same guy. Okay, now let me show you how it looked like. Okay, now I'm going to give it like 100, 200, 300, 400, and 500. What is this? Can it be a list? Yes, it can be a list. Okay, but this is an array with here homogeneous values are there. Homogeneous is same data type, all are integers only. So this is an homogeneous values over here. Okay, now this is an array. Okay, array. Now this, if you see this, the values are arranged. Okay, values are arranged in one direction. This is the direction the values are arranged. Okay, now this is the array of how many elements, guys? 5 elements. Array of 5 elements. Okay, clear? Now, and each and every object in the NumPy will be under the ND array type. Okay, each and every object means this can deal with n dimension, means this is an one object of what dimension it is? One dimension. It is a one dimension. Dimension is direction. Now let's take it the two dimension, guys. I'm taking it like 100, or let me show you like this. This is one dimension. Okay, one. How many one dimensions are there? 2, right? How many one dimensions are there? 3. So what is this totally? One dimension or two dimension? Two dimension. It is 2. It is, you see this here, this is one dimension data. This is one more one dimension data. This is one more one dimension. Then 3 one dimensions I clubbed together. So now data is arranged in 2 dimension. What are the 2 dimensions over here? 2 directions. This is one direction, and this is one more direction. Okay. Now when you are going to deal with this one, see this. This is usually we will deal with a graph. This is what is called as a graph. This is having the one dimension over here. Sorry. Now you see this. This is the x-axis, and this is called as y-axis. So what is the 2-dimension array means? It is the combination of multiple one-dimension array combined together will become a 2-dimension array. Okay. Now 1 dimension means it can be this way, okay, this way, or it can be this way also. Anything it can be. This is also called as a 1 dimension, right? What is the dimension here? 1 dimension. Which direction it is the values are arranged? In the y-axis. Okay, 1 direction. This is, there won't be any y or x-axis while dealing with a 1 dimension. Only 1 direction. When there is a 2 dimension, then we have the y-axis and x-axis. Now, how to define? Now, a 1 dimension is when the values are arranged in 1 direction, that is called as 1 dimension. Now, 2 dimension is when the values are arranged in 2 directions, then it is called as 2 dimension. In other way, we can also say that it is the collection of or combination of 1 dimension. It is a collection of 1 dimension data. Okay. This is like 1 dimension and this is 2 dimension. Now, if I am having a single value, let me write it down over here, a single value. I will write it as, I will take this. There won't be anything like that. Okay. Like this, I am having a single value, guys. Now, this single value is called as 1 dimension or 2 dimension? Which direction it is going? Which direction? There's no direction for this. Single value, there's no direction. So a single value without any direction is called as scalar. Okay, when a single value without any direction is called as scalar, guys. Whenever we are going to use this term a lot and lot in the future, remember this. Scalar means a single value. There won't be any direction for this. Now, what is one dimension? When the data is arranged in one direction. And you can also say that a group of scalars which are arranged in one direction is called as one dimension. Here you can say one dimension is a data array or values arranged in one direction is called as one dimension, guys. Okay. Now this can also be defined as it's a collection of or combination or collection of scalars arranged in one direction. You can also see it like this. Because you can see this, if you take it, 100 is what? It's a scalar. 200 is what? It is a scalar. 300 is what? It is a scalar. They are arranged in one direction, right? That is the reason why it is called as a one dimension over here. I'll keep it up over here. Okay. Now, this is the collection of one dimension data is called as two dimension, or a scalar which is arranged in your collection of scalars which are arranged in two dimension is called, or two direction. First one is values arranged in two direction. And also you can say that it is a collection of one dimension data. Okay. Collection of one dimension data, or you can also say that collection of scalar which are arranged in two dimensions. Okay, this is the way you can define your two dimensions. Okay, now remember this. This is a scalar, right? A collection of scalar is called as one dimension over here. One dimension. I will just keep this one inside this. One dimension. Okay. Now, this when the collection of scalars which are arranged in one direction is called as one dimension data. This one dimension data can also be called as vector. They call it as vector, guys. Okay. Now that when the collection of one dimension data is called as two dimension data, two dimension array, this two dimension array is also called as matrix. Remember this, matrix. Now the limitation of the matrix is it can hold only two dimension data. The vector means it can hold only one dimension data. Scalar means it can hold only one value. Got it, guys? Only one value. Any questions? Here, guys, any questions? Now let's move forward. So the power of NumPy is it can deal with n dimension data, n dimension array. N dimension means you can have the 3 dimension, you can have the 4 dimension, you can have the 5 dimension, 6 dimension, 10 dimension. Any dimension you take it, you can deal with the array. Okay, that is the power of the NumPy. So if you take it, this is my two dimension, right? I'm taking it as 2 dimension. This is my 2 dimension. Now, simple way you have to remember one thing is scalar, collection of scalar is called as vector. Vector is nothing but one-dimension data. Collection of vectors is called as two-dimension data. Right? Collection of vectors is called as two-dimension data. Now, what is a three-dimension data? Collection of two-dimension. It's simple. Collection of two-dimension data is called as, three-dimension data. Now, usually it is shown in the form of like this, guys, cube. It will be making like this, a cube or something like that. I will show you. If you take it, this one, multiple versions of this. Like this. So this is one two-dimension data. There will be one more two-dimension data. There is one more two-dimension data and one more two-dimension. Okay. Just like this is your first page. Then this is what? Second page. This is what? Your third page. This is what? Your fourth page. Okay. In the first page, you have this data 100, 200, 300. Now the second page is having like 600 to 1000. Something like this. So you have it 600, 700, 800, 900 and 1000. Like this, the data will be there. Now next, like this. This will be the first page, second page, third page, fourth page, like this. So you can pull it up the page like this. If you wanted, you can pull up the page from this. So it is a collection of dimension data. Now you may say that, okay, we can't, it will be in the form of a cube, guys. Collection of two-dimension data, which is in the form of a cube. Now this you can show it. Now in Numpy, you can't get the data in this way. So what they will be showing you the three-dimension data is, it is collection of two-dimension data, right? This is one two-dimension data and there is one more two-dimension data they are going to keep it here. How many two-dimension data are there? Two two-dimension data are there. Okay guys, two two-dimension data are there. This you put it in the array. Okay, this is the way you will be getting that three-dimension data. This is now four-dimension is, what is four-dimension? Collection of three-dimension. Now, if you want me to show you graphically, means it is our brain is not so much advanced that we can't imagine the things beyond three dimension. It's difficult to imagine the things beyond three dimension. Okay, so the best way is audio is gone. Can you hear me now? Okay, check your audio. Okay, now this is a way, simple way to remember, guys. I told you what is a scalar means single value. Collection of scalar in one direction is called as a vector or one dimension data. And this collection of one dimension data, when you put it in together, is called as a two dimension. That is also called as matrix. Remember this matrix. What is the limitation of the matrix? You can arrange only the data in the two dimension. You can't arrange more than that. Okay, you can't arrange more than that. Okay. Now, what is the power of Numpy is Numpy can hold the data of n dimension. There is no limit for that. So this is two dimension. Now, collection of two dimension is called as three dimension. Collection of three dimension is called as four dimension. Simple. Now, if you want me to show that four dimension, let me edit this one. Yeah. Now, this is three dimension. Now, we are going to keep the four dimension. This is one three dimension, right? This is one three dimension. Give it the one more three dimension. What will happen? This will become the four dimension. Sorry. Okay, guys. Clear? Now let's see the indexing. Okay. I just now showed you Amitabh the four dimension data. Now let's see this one. This is my scalar. You know this. This is a scalar. Now I am going to take the. This is my Now this is my one dimension data, guys, right? This is my one dimension data. I will write it up over here. One dimension data. So this is called as vector also. Now if I want to do the indexing over here, can I do the indexing on this? Yes or no? Yeah. What is the indexing? Where 0? 0, 1, 2, 3, 4. Right? Now this is what you call it as indexing. And there is one more way we can do it. What is that? -1, -2, -3, -4 and -5. This is called as negative indexing. This is called as positive indexing. And this is negative indexing. Negative indexing starts with -1 and positive indexing starts with 0. Now this is okay. Now let's deal with the two-dimension data. This is our two-dimension data. Okay guys, now before getting into two-dimension data, now I give the name of this one is maybe array 1. Can I give it? Array 1. I gave the name. Now I want to extract, okay, 400. Tell me. ARY1 of 3 or -1, right? ARY1 of -1. Here -2. I was testing. Okay. Now next is, now let's deal with this one. What is this? Two-dimension data. This is two-dimension data. Let's go down. Now I will change the values a bit, guys, over here. I will give it as 600 and 700, 8, 9, and 1000. And this one, right? Okay, let me get this one as 1000. 1000, 3, 4, and 5000. Okay. Now this one I will make it as maybe 999. Okay. Now, wait. You can talk to me, no problem. Now, how the indexing goes, guys, here? What is this? Combination of one dimension array. Now this is called as row, right? You know this. This is called as row. This complete. This is called as row. One row. That is one dimension is one row. It is. Now this is called as second row. This is called as third row. 3 rows. Now these rows I want to give the indexing. This I will make it as 0. Okay, before that let me remove this all cuttings. Okay. Now this is 0, this is 1, this is 2. Okay. Clear, guys? Remember this. This is 0, 1 and 2. And prioritization in the Numpy. Remember the word? Prioritization in the Numpy is given to the rows first. Okay. Now this one in the columns. This is columns. 1 column, 2 column, 3 column, 4 and 5 columns are there. 5 columns. How many rows are there? Rows are 3 and columns are 5. Now the columns I want to give the indexing. This is 1 column, so I will give it as 0. This is 1. This is 2. This is 3. This is 4. Okay. This is the way the indexing is given. This is the row indexing. This is called as column indexing. Okay. Row indexing and column indexing. Now, how many rows are there? Rows, comma, columns I will give it. Okay. How many rows are there? 3. How many columns are there? This is called as shape. Shape of array. Okay guys, this is called as shape of array. Clear? Now what is the, now there is, how many elements are there? 3 into 5. How many? 15. This is the size of the array. Size of the array. Size means number of elements inside an array. Now shape means number of rows and number of columns. Again, first it should be rows followed by the columns. Now next one is, what is the dimension? 2 dimension. So it is a 2 dimension. So in order to get a shape of an array, now this I am giving it is, name is ARY2. Okay, remember this. In order to get a shape of an array, we are having an attribute called as ARY2 dot shape. Attribute, this is not the function, this is an attribute directly, no need of giving the parenthesis. So ARY2 dot shape is equals to, you will get this. Okay, this will work for you in NumPy, Pandas and TensorFlow, all the cases. Okay, you are learning once and using many places. Now, in order to get the size, ARY2 dot size. When you do this, you will get the size. Size means number of elements. Now, this one, ARY2 dot, there is something called as ndim. Ndim. Ndim is an attribute which tells us what is the dimension of the array. What is the dimension of the array will be given to you by the ndim. Remember this, guys. Okay. So what's the time? It is morning 5 o'clock. Okay. Now, if you want to see the data type of the array data type, that is element of the data type. Okay, so this what value is this? Now if I get any value, you can take it, because array will hold only one type of data, right? So there is something called as d type, ARY2 dot d type. Okay, I will write it down. ARY2 dot d type. So this will d type will give us the data type of the values of the array. Values of array. Okay, that is, this is the way you will be. ARY dot d type. Okay, guys. So this is the, these are the things you have to know about this. Okay, let's play with these things a bit. Now I want to get it. Now this is a way you have to know this. Now I want to get it like maybe 900. Okay, 900. Now which row it is? 900. Second row. Row is equals to 2. And which column it is? Second row. Index is what? Sorry, index is what? 1. Index is 1. Now which column? Index is 3. So when you write the shape, what will write first? Row, and followed by column. Now when you are going to extract a value, now if you want to do the indexing, ARY2 you will write it, right? ARY2. Now in this is the, you will do the indexing. If you want to get it somewhere, we have done it up over here. If I want to get it like 400, so what you did it? AR1 of 3, okay, or AR1 of -2. In the same way, this square bracket will be divided into 2 parts. Why? We are having the rows and columns. So we will be dividing this one into 2 parts. That is, first one will be for rows, second one will be for columns. Now, which index is a row? 1. Which index is a column? So when you do this, you will be getting it like 9. Okay guys, 900. That is 1, 3. There is a way is also there. Now this will be quite confusing. That's why I didn't tell you. If you want to deal it now, how many dimensions are there here? Give the 2 square brackets. First one is for the row. Second one is for the column. Now 1, 3. When you do this, you will get it 900. Like this also you can do it. But why I'm doing this is I'm preparing you for the slicing. I'm preparing you for the slicing. So for this, you will write it as AR by 2 of inside this. Now how many parts? 2 parts you have to give it. First one will be row followed by column. Row is equals to 1 followed by the column is equals to 3 over here. Okay guys, like this you are going to. Now let's take it one more, like 5,000. How to extract the 5,000? 5,000 I want to extract it. So which row it is? Row index is 2. Row index is 2 over here. And column index? 4 is a column index. Sure, 4 is a column index. Now then how you will write it guys? Now AR by 2 square bracket. First you will be having 2, 4. 2, 4. Okay guys, clear? Now this is the way you will be dealing with the 2-dimension data indexing. Okay, when you deal with the 2-dimension data here. Now when you deal with the pandas, there is a slight difference will be there. So we will be seeing that one later on. Now as of now, this is the 2-dimension. This is also called as matrix. This is called as matrix. Now then let's deal with the 3-dimension data guys. 3-dimension data. Now where is our 3-dimension data? This is the right. This is the 3-dimension. Let me take it completely. Okay. Okay, 3-dimension. So here, what are the different parts we will be having? 3-dimension. First one will be the 3rd dimension. Okay, first one will be the 3rd dimension. Next, followed by rows, followed by right. Now, 3rd dimension is which one? The blocks. This one and this one. 3rd dimension. So, if you want to deal with the indexing, if you want to give the indexing, this block will become 0. This block will become 0. This block will become 1. Okay. Now let's see the indexing of the rows. Now first priority will be given to the 3rd dimension. Then rows. Then followed by columns. Now row indexing 0, 1, 2. Now here 0 or 3. 0, 1, 2. Now this is 0th 3rd dimension, 0th 3rd dimension, and this is 0th 3rd dimension, 0th row. 0th 3rd dimension, 1 row. 0th 3rd dimension, 2 row. You have to remember like that. Okay. Now, what is the columns? Column indexing. Okay, guys. Now, the priority will be the prioritization will be like this. First, third dimension, third dim, followed by rows, followed by columns. And this should be inside the square bracket. And if I'm giving the name to this one as AR by 3, because third dimension, right? I'm giving it as AR by 3. Okay, I will give it like this. So this one, I will give it as here AR by 3 of 3. Okay, 3 of third dimension, comma, followed by rows and followed by the columns. Okay, guys, followed by the rows and the columns. Now, you are clear now. Okay, now fourth dimension, 4 parts. Fourth dimension, third dimension, rows and columns. 5 dimension data is there. Then you will give the 5 parts inside the square bracket. Okay, now if there is a fourth dimension data is there, AR by 4. Okay, how the indexing will be done? First part will be fourth dimension, followed by third dimension, followed by rows, followed by columns, like this. If there is fifth dimension, you will be doing the same thing with fifth. 5 parts will be there. Now you see, you will be having fifth dimension data, guys. You will be having fifth dim, comma. Now this I will give it as AR by 5. Okay, guys, like this you have to do. Okay, just remember this. Okay, this is very, very important. Okay, now in this I want to do the slicing, guys. I'm saying not slicing, I want to do the indexing. I want to get it like, again we will get the 400 over here. This 400. This 400 I want to get it. How you get it, guys? Huh? Array 3 of, now here let's do it over here. Array 3 of, now first one will be over here, what? Third dimension. Which third dimension it is? Which block it is? 0 and 1 both are there. 0 block it belongs to. So you will give it as 0, comma, followed by 2, comma, 3. Okay, 3, because this is 1, 0, 1, 2, 3. Okay, 3 over here. So you will be getting what? 400. Now I want to get it over here, this part. Then what? ARY 3, 1, 1, 1, 1, 1. Okay, like this you are going. Okay, is it clear, guys? Now let's deal with it. Now you are clear with the indexing. Now you have seen the multi-dimension arrays and all those things. I think that you should not have any problem with anything. Now the thing is how to create an array. First of all, how you will create an array. Now I showed you like this. How you will create this third dimension array? How you create this array? See, in order to create array, there are like 4 different ways are there. 4 to 5, I don't remember. Let's go. Like the types of creating the array. First one is called as traditional way, which is using an array function. We will be doing the traditional way with array function, ARRY array function, like this. Okay? हमने बुक नहीं लाया क्या? मूवी बहुत देखते हो क्या? आदत से मजबूर है क्या करें? Okay? Traditional way. Second one is homogeneous. Now homogeneous way is now this is you can create a structure of the array with the homogeneous value. Default values will be there. With the homogeneous value you can create it. One is called as ones. function using the ones function. Second one is a zeros function. Zeros function. Okay, this is ones function and zeros function. The syntax will be, the syntax of ones will be ones np. Np means numpy, or you can say that numpy dot ones. Okay guys, ones. Clear? Now this, by using this, what we are going to do it is, sorry, ones. Now by using this, you can create the desired shape array with all one value, with the one as a value inside this. Now you have to give the shape over here. Inside this, you will give the shape. Shape. What shape of the array you wanted? What shape of the array you wanted? And it will create an array of that shape with all the values as 1. Okay, all the values of the 1. Now you have the option of give the desired shape, but value will be 1, which will be in the float format. Default format is float. Okay guys, clear? Now let's see the next one. Like if we want to do the zeros, so we have to provide shape, and values will be, default value will be 0. Default value will be 0. And the default format is float. Default is float format. Okay, I got some questions. I'm going to repeat it because once we are doing it, that one in the practicals, I will repeat it again. That is a name I gave it. Array 2 means, that is a name I gave it, which is 2 dimension. For that I gave a name. And array 1 means 1 dimension. Okay. Now, is there any 4 dimension data? Yeah, I'll show you. Now, this is the second way of creating an this is a 2 ways, like one is ones and 0. Now, next one is the syntax is same guys here. Here, I will give it as zeros. Okay. Now, in this, you have only the choice of giving the shape, not having the choice of giving the value. Value is always 1 or 0. Remember this. Now, the third way is called as diagonal. Okay, diagonal B. Now, in this, we are having the function called as I. I is a function. And one more is called as identity, I think so. Identifier. I think that identity. Let's see this. I will check it out and I will see it. There's one more is called as identity or identifiers. Now this is, it will display the data in the form of, desired shape. It will take the desired shape. Now whatever the shape you have to give it, the input will be the shape, guys. How you will do it? The syntax will be numpy dot I, and inside this you will give the shape over here. Okay, inside this you will give the shape, and whatever the shape you will give it, right, it will create an array with all zeros, and only the diagonal will be ones. Only in the diagonal it will be ones. Above the diagonal line and below the diagonal line, it will be all zeros. Okay. Now identity is also same. I think so. Not I think so. I'm sure of that. But whether it is identity or identify, I don't remember that. Huh? Identity or identify. Always correct. Here. Now, how the data will be looking is, now if I have an array, just take it, this is an array. Now, one, like this. This is the diagonal. This is the diagonal line. All the along the diagonal line, you will be having the one. Above the diagonal line and below the diagonal line, you will be having zero. This is below the diagonal line and this is the above the diagonal line. These are zeros. Okay, this is what is called as. Now the difference between these two is this requires to give only one value. The shape you will be giving one value. It will prepare the square matrix. That is, if you give 4, it will create a matrix of 4 rows and 4 columns. Then you can get the diagonal line very easily. You get the diagonal line when it is square only, like this. So, but the I is having the option of giving your rows and columns as you like it. If you give one value, it will create a square matrix. If you give 2 values as you like it, it will create it. But the diagonal line will be the starting from the whatever the line is. If this is the one you are giving, this is how many? 3 rows and 5 columns, right? This will be 1. Exactly diagonal, this will be 1. Exactly diagonal, this will be 1. Remaining all will be zeros. Like this. Okay. Now, next one is called as numerical form. First one is called as A range. A range. Now, A range is very much similar to that of range function, guys. Range function, what it will do? Generate the values, right? By taking the 3 values over there, you can generate the value, starting value, ending value, and step. Good. Now, this A range is similar to that. Again, you will be doing it. Here, numpy, I will give it as numpy dot A range. Okay, guys. In this, you have to give it what? Number range. As that. Okay, number range, you know the 3 values, start value, end value, and the step. Okay, now inside this, always you will get an 1 dimension data. Is 1 dimension array. One dimension array. I'll put it over here. Okay, I'm giving it extreme left, right side. Please check it out. So this is now one more one is. Now remember this. This case, you can give it the shape. You can give your desired shape. But values will be default values will be given over here. Default. Okay, default value. Okay, now in this case, you can provide it desired shape. You want it desired shape, you can provide it, but the values will be either 1 and 0 combination. 0. Remember this, 1 and 0. Okay, you can provide the desired shape, but the values will be in the combination of 1 and 0. Now, in this case, the numerical form or numerical way, we call it as, in this way, you will not have the choice to provide the shape. No, only you have the choice to provide your number range. Okay, we can provide our desired number range. And output resultant will be one dimension only. Always one dimension. Okay. Now there is one more is there over here called as Lin Space. Lin Space. This syntax we are going to talk it, guys, again. Here, okay, let me write it down over here. The number range consists of start value, and end value, and step over here. Step. And in this, we are having the same thing. You will have the same. You will be providing the number range. Numpy dot a range. We are going to give it as number range. Number range with number of values. Okay. Number range and number of values. Now, what is the number range will be something like this. Okay, let me write down the number range over here. Start value, stop value, and numbers, number of values. Start value, stop value, number of values. What is this is? In this case, in the first case, you will give the starting value. Like if I am giving it something like this, you are going to give it num, okay, N-U-M-P, numpy dot a range. You will give the starting value 1, ending value 10, and you will give it 1. So what you are going to get it, guys? Here 1 to 9 you will get it. 1 to 9 values you are going to get it over here like this. And 9 like this you are going. In this case, what we will be doing is numpy dot linspace here. Linspace. So what you will be doing over here is numpy dot linspace. You will give the starting value 1, ending value like maybe around 3. I am giving it, and in 1 is a starting value, end is a 3. In between that, I want to generate 50 values. So it will be generating the 50 values between the start value and end value with the equal intervals. It will be equal intervals. With the equal intervals, will be generating. So the number of values means like the default will be 50. The default value is 50. So it will take the starting value, ending value, and generate the desired number of values with equal intervals. Okay. The start and with equal intervals. This is important. With equal intervals. Okay, guys. Clear? Now, there is one more is there. This is very, very important. The one which we are going to talk about. That is called as range. So, random. Random. See, under the random, we are having a multiple will be there inside this, like this. How you will be having under random numpy dot random dot rand. You have first one rand function. This will take the shape, input will be shape, it will take the shape over here. Shape, you can give it the shape over here. Shape. And it will be randomly, it will be generating the values, or it will be generating the values based on the shape, randomly taken values, and it will collect the values randomly, or it will generate the values randomly in our desired shape. But the thing what you have to remember over here is rand means it will generate the random values in our desired shape. It will generate the random values in the desired shape, but only thing is that it will generate only positive values. There will be no negative values. So rand function will generate all the positive, randomly generated positive values in our desired shape. An array as of desired shape. By creating or generating all random positive values. Now again, this will be float values, guys. There will be float values, not the integers. This will be float values. Okay. Now there will be something called as numpy random dot rand n. Now this is very much similar to that of rand, but only thing is that it can generate, it will be having a negative values. N stands for negative. It creates an array as of desired shape by generating all random positive or negative values. Again, it will be in the float format. Remember this. Okay. Now there is an last one. Okay, last one. Numpy dot random dot rand int. Now this is like this is the only array or only format where you can have your desired shape and your numbers, whatever numbers you need. This is the only one. In the previous all case, either you can provide your desired shape or your number range. But you know, this is the only format or function which provides us, which gives us the flexibility of giving our desired shape as well as number range. So first you will be giving the number range, that is nothing but start and stop, start value and stop, and then you will be giving the shape over here. Inside this you will be giving the shape. Okay guys, like start, stop and the shape. And here it is an integer values, guys. Random integer values. Okay. Now these are the different ways you can create the array. Okay. Now these are the different ways you can create the array. Now you know all the things, right, about the array. I think so. You know what is a one-dimensional array and what is the history of the NumPy array. and what is the one dimension, two dimension, three dimension, how to extract the values from the one dimension, two dimension, three dimension, and how to create an array over here. What are the different ways of creating the array? Let's do one after the other and let's do it, guys. Now, okay, here we are having two options. Now we are not going to use the PyCharm anymore. That's the end of the PyCharm. Now here we have the two options. Either we can go with the Google Colab or Jupyter Notebook. Anything we can try it out. So let me show you the Jupyter Notebook first. So you have to install the Anaconda. I have some steps are there. I'm having that steps. I will just share you that document today in the classroom, the step by step. But first you download it. How you have to download is Google and say that Anaconda download. Okay. Now Anaconda is nothing but it is an environment area where you have all the different editors. Different editors are there. Now this is better to download directly Anaconda and from there you use the Jupyter Notebook. Okay, that is the best. But you can directly download the Jupyter Notebook also. Okay, Jupyter Notebook it's a third-party tool. The Anaconda has got a tie-up with them and they dump their Jupyter Notebook inside. There are two versions are there in the Jupyter Notebook. One is the Jupyter Notebook, second one is the Jupyter Lab. Jupyter Notebook is just like Colab, just like how the Colab will be there. We have seen the Colab multiple times, it will be like Colab. And Jupyter Lab is extension of the Jupyter Notebook with file hierarchy will be shown. How you will show the file hierarchy in the PyCharm. Left side you will have all the files, right? Folders and the files. Like that you will be having. Okay. Now this is where you have to go, anaconda.com. Please check it out these sites. Don't take it from the third party or somewhere else. The virus will be loaded up. So now next is click on this, and once you click on this, it will be start downloading. It started somewhere. Yeah, it started. It is around 500 plus bytes. It is MB. 500 MB. Okay guys, this will be downloaded, and after downloading it, I already have it. Okay, after downloading, just click on that. Automatically you will get a wizard, and you will be having nothing special you have to do it. Just click on next and next and next. One place you will be getting two check boxes. One will be already clicked down. The up one, it will ask you to add to the environment variable. That's what it will say. Just click that checkbox and move forward. So only that checkbox you have to click it. There will be two checkboxes. One will be already clicked and one you have to do it. That is mandatory. Okay. And after that, it will take it like first 80% of the downloading will be done in 2 or 3 seconds. Next, that 20% of download, it will take 10 to 15 minutes. For me, it took like 10 to 15 minutes. For maybe based on your internet speed, it will take it like at least couple of minutes. It will take it. It will not happen in because a very huge one. Okay, remember that. And once you do this, then go and search over here, Anaconda Navigator. This one, guys. Can you see this with the symbol over here, round circle? Like this, you will be having it. Click on this. I have it another version, that's the older version over here. Sorted. Be very careful. It will be corrupted very frequently. This will be corrupted very frequently. Amen. Look at that. Now it is opening this. Yeah. Both will be same. I will show you the similarity. You have seen the collab earlier. And first and important, very important is if you want to play with NumPy, if you want to start with NumPy, import NumPy first. Now, this is the way your Anaconda Navigator look like. This is a one more editor of Anaconda people only, this one. Okay. Now, this one data lore is again, this is a part of PyCharm people. It looks very much similar to that of, Jupyter Notebook. Now, these all will be taking the help of an browser to open up. They don't have an application of their own. They will take the browser to open up. Now, you have to give it here. All this, create an account or sign in with the Google or something like that. With the Google. Just to show you which one you want to practice it. Practice multiple things and keep it in your resume 2 or 3. That will be a lot of weightage for you. Now, next one is here, Jupyter Lab. Now, this is a Watson is again another. This is Watson is a chatbot, intelligent chatbot. It is built by the IBM people, and this is the Jupyter Lab, which I was talking about, which is an advanced version of the Jupyter Notebook. This is the Jupyter. This is the Jupyter Notebook. If you click on this, you will be again. It will take the default browser help and it will open up. All these things will be running on the browser, but it will not be connected to internet. It will be locally installed, but it will take. They are not having their own application like PyCharm. They will take the help of the browser and it will run it. Now it is asking me which one you want me to open it with. Let me go with this one. Internet Explorer. Okay, let me see this. This is the location where your files, this is where it is connected as. The Jupyter Notebook, complete Jupyter Notebook will be like this. Okay, this is the location where the files are. Now you can create a folder over here. I will go to the new. Okay, can you see the new over there? Top right. The new, click on this and say that go to the folder over here. Once you click on this, it will create a folder. Where it is down somewhere, it will create Untitled folder over here. Can you see it? Untitled folder. Click on this and go to the rename over here. Don't ask me why you're going up and down. That is the Jupyter Notebook is like that. Okay. Now here I clicked it on this and then I will go to the rename. Then I will rename it as Data Science 9:30 AM. Okay, something like this. Okay. Now here it is the folder. Can you see this? Now I entered into the folder. Now this is a root folder, guys. Here you can see this. Click on this, you will enter into that folder. And I want to create the file to write it, notebook. Again, go to the new. Click on this. You will be finding Python 3 Python 3 kernel, like this you click it on, you will be getting it. This will be just showing it. I think it will work. Here the file name is untitled file. What happened? This one is not. But pass. Not showing this. So when you click on this, you will be getting it. It will directly. It's not opening. Huh? Check other browser. That's what I did. It is asking me authentication. I don't know what authentication. Yeah? That this is when I'm dealing with directly with the Jupyter, right? So if I want to go directly with the Anaconda, no need of doing that. This one. But why the server is not working like that? Huh? Let's take the new version. Copy the URL. Complete URL. Which one then? Internet Explorer I closed it. Let me try it out with this one at least. Yeah, I got some suggestion. My system time is it? Now it's showing me the same thing. So now it should work. Huh? Match. Let's copy it. URL. Where I have to put it? Google Chrome. Huh? That's what I did it earlier. I think so. Google and leave it over there. Huh? This one, huh? Till here. Invalid credentials. Mara Surra. Huh? It's gone. I think that there is a problem with this one. So it's showing the same thing. It's Edge, the latest one. I'm downloading the Edge. Just give me some time. Yeah, guys. This is the way the Jupyter notebook look like. Now, this is the actual your file structure. From here, when you're clicking, automatically you will be opening up over here. Or let's do it once again. I can delete these things. I will create a new file. Okay. Again, it will open up over here. Okay. Now you can change this one by giving that. I will say that numpy 1. Okay. Now first and foremost is import numpy as np. Okay. Now as long as it is processing, you will get a star. Once it is processed, you will get a number over there. Okay. Now actually this is numpy. As np is, I'm giving a alias name to that. Okay, why I wanted to use this one each and every time, the numpy. So numpy writing will be a bit, overweighted. So I gave it as a small name as np. This np is a coding standard which will be usually it will be recognized around the world. Around the world they will be giving it. Whenever you see np, that means to say that numpy. You can give your name also, no problem. But it's like that. Now I want to create a numpy array. Now np dot array. I told you the first one. Where is that? The traditional way array. This should be numpy. Numpy dot array. Okay. Now this is the one. Now you here you will not get a dynamic help, guys. No, like how we get it over here in the here Google Colab. This is a Colab and this is a Jupyter notebook. See the similarity. They are same, almost same. Now there is something called as Jupyter Lab also, that is even flexible. And here you should observe one thing is this files extension will be the same as this IPYNB. Okay, IPYNB will be the extension of this. Now in the PyCharm we will have .py. Remember that. This is the one. Here it is the lab. Now here this is the one which I created just now. If you go inside this, there is. Now if you want to create a new sheet, you have to use this one called as Python. Now the advantage of this one will be like, it is pretty easy. It is similar to that of your PyCharm. Okay, but here the coding you are writing, the files will be over here. Here you can't see the file structure over here directly. You can't see it. You can over here. You can see the file structure, whichever the file you want it. Okay, guys. Now let's move on. I want to create one. Let me increase the size of this. Okay. Now I want to create an array over here. I'm creating the array with some values. Okay. Now I will give it a name as ARY1. Now ARY1 is equals to this. It shows like a list. If you say print ARY1, you will get it just like the list only commas will not be there. Now you want to see the type of ARY1, you can do it something like this numpy.ndim. Okay, ndim type. And I told you, like, there are some attributes are there. Okay, like if I want to find out the shape, ARY1.shape, this is an attribute 4. It's a one dimension, right? 4. Now ARY1.size will tell us the number of elements. Now you will get it 4 elements. Dimension ndim. What is this? 1 dimension. And D type is what is the type of the element? Element what type it is? Int 32. Int 32, 64, 16 and 8. This is a dynamic, primitive data types, guys. And if you want to see the item size will be 1, which will give us the size which occupies by your array. 4 bytes it is occupying. Each element is occupying 4 bytes. Okay, remember that each value is occupying 4 bytes. These are some of the attributes over here. Just I created the array with what? Using the array function over here. Now, if I want to create a 2-dimension, then I will create it something like this, np.ary, and inside this I will give it inside. Now, this is the actual values where I am giving it. Okay, inside this I will give it on the row basis. First row I will give it as 10, 20, 30, 30, 40, and next row I will give it as like 100, 200, 300, and 400, something like this. And I will give it name as AR2. AR2 dot shape. You will get it what? 2 rows and 4 columns. AR2 dot ndim gives us the dimension of this. Okay. Now the size is the one which you have to know it. Now I don't want the, here I can change the type also. D type is equals to, I can give it as a float. Now I don't want the values to be in the integer. I want it in the float. Just you can give it as a float. The float. Get it in the float. Can you see it? Now, if you are having like this is a combination I'm having, just see this. This is a 2-dimension. Okay, I created the 2-dimension myself. Now here, I'm giving 1 as all are integers. Only 1 is the float. Now let's see this. What will happen? Now, in order to run this, I'm using the shift enter. Shift enter will execute the current cell and it will generate a new cell also. Shift enter. Can you see this? Everyone got into the float type. Even though I'm not, okay, let me remove this one. Maybe this. Now, let me do this. Now you will get it all of them as again. Okay, now everything got into the float. Now, if I remove this one and I put a 0 over here, all of them are the float type. If you want to see the ARY3.D type, what you're going to get it? Float 64. Okay, 64. Now I want to create an, if I want to make a note of this, then I will use the markdown. Markdown is just like giving some note inside the, like how you pass it on the comment, the same way it is. You can put on a note over there. Now here I will say that, once array. Just got it once. Okay. Now if you want to run this one, you can use it. If you want to make it a bigger, you have to use the HTML tag. H1 is a header tag. Now you see it looks much better. Okay, you can do it. Now I am doing with the homogeneous arrays, guys. Now np dot once. Okay, once inside this give the shape. I want it 4 rows 6 columns. 4 rows 6 columns. Now once I do it, I am going to get it an array of 4 rows 6 columns with only one inside that as a value, and default will be float. Can you see this? Now if I want to get to this one, what is this? How to get to this? Tell me the index. 1, 1. That is what I have to give it. Now I will give a name to this np1. I will give it np1 of 1, 1. You will be getting this. Okay. Now I want to change that value. How I'll do it? How you will do it in the dictionary? Identify that one and assign a new value. The same way it is. np1 1, 1. I will give it as here 100 or 111 or 999. Let's see. Yes. Clear. That's why I said it, like just go through your dictionary and your list, it will be much easier. Now this is, now what is the purpose of this? Can someone see me? What is the purpose of one's function? Create a dummy array. Create a dummy array and then you can put on the values into that. That is the use of this. Okay, this is a dummy array. Now, if I want to go with that, this is 2-dimension, right? How to get the dimension? NP. Okay. Now here, I want to create the 3-dimension one. NP3 is equals to, I have like NP.1. I'll give it a 3-dimension. So 2 blocks, 4 rows, and 6 columns. Okay. Now see this. Now you can fill up. Now 3-dimension directly I can't make it like this, right? Doesn't make any sense also to making it like this with the values. Then I can put on the values as per my requirement over here. Now if I want to get it, now see this, if I give a, sorry, I will do it like NP1 is there. What is this? This is a 2-dimension data. Now if I do the for loop over here, just take it, for I in, you know, like NP1, what are you going to get it, guys? Huh? What are you going to get it? Row by row. You are going to get it row by row. Or in the shape, whatever the starting one will be there, that is what you are going to get it. In the shape, rows, comma, columns will be there. So you will be getting row by row over here. Now you see this, import time. I will use it, time dot sleep of 1 second. Now I will run this one. You will get first row, second row, third row, fourth row. Row by row you are going to get. Now we have something like this. What is this? 3-dimension, right? NP3 dot ndim. What is this? 3-dimension. Now if I do the like NP3, what I'm going to get it? Block by block, 3rd-dimension, block by block you are going to get it. Print I. Okay, when we do this, you will be getting block by block. We got it block by block. It was very fast. First block, second block. Got it? Now, if I use one more array for loop, row by row. If I use the one more for loop, guys, over here, I will get it row by row. For j in I and print j. What you are going to get it? Row by row. First, you will get the block, and inside the block, you are going to get the row. Now, let me do this. Now, let me run this. Next block. Okay, guys, clear? So, if I do it one more, element, which element you will be getting? First row, first element, second element, third element, fourth element, then second row, first element, like that you are going to get it. Okay. Now let's do with the zeros. Zeros also similarly, but only thing is that inside this, instead of ones, you will be getting zeros over there. This is also specially used for creating the, you know, the dummy array. H2. Zeros. So I will give it np dot zeros. I wanted like 3 rows, 5 columns. Now this should be inside nested tuple like this. Okay. I will give it as A1, AR by A1 I will give it, or Z1. Z1 is equals to like this. This will be again float. I don't want the float. I want int means d type is equals to int. Got it? So you can do it like this. Now again the similar things, guys. Whatever you can do it, the same things you can do it over here. The next one is I over here. This is specially used to give the values in the diagonal format, right? The diagonal will be ones. np.I, and inside this, when you are giving it, don't give it in the nested list. Just give it the value over here, 4. 1, 4. When I give the 4, it will create a square matrix with 4, 4. Now, when I do this, I'm going to get the output. Okay. This I will store it in an E1. E1. Now you want to see the I function details, right? I. Now use the shift tab. When you use the shift tab, you will get a help over here. Can you see this? Now you will not get the help dynamically. You have to request for the help. Shift. Now click on the shift tab. You will get the help. Now this is very small. You want to see more. There is an up arrow key. Click on the up arrow key. You are going to get all the details over here. Can you see this? No, you want it separately. You want to see it. Then you can go with here. If you do this, it will open in the tab. Now you will have all the information, like with the examples, you have everything. Now this is the best way of taking the help, not from the Google. It's the best way to do it. Now again, I will show you. If you wanted the help on this, just give it shift tab. You got it? And then click up. Okay, and this one. You will be getting it completely over here. Here, guys, help in the tab. In this, you will get it directly over here. Import numpy as int. Now, np.I. I'm doing it here only. You will get it. Serious, here you will get it. Just like how we will get it in our collab, like this, you are going to get it over here. So that is the difference. So, this is lab. This is lab. This is the Jupyter notebook. Now, next do with the I is there. Now, I wanted to do with like 4 rows and 5 columns. I want to do it with the 4 rows, 5 columns. Then you will be giving us E2. Okay, guys. Now you see this. It will start from here diagonally. This one, and this one. Now there is something called as identity also. Is there identity? Yeah, identity is there. So here I will give it only one value, 4. Say it 4. If I give it more, then it will trigger an error, I think so. 4, 4. Cannot interpret 4 as a data type, sticking that as a data type. So you can give it only one value. Okay. Now this is quickly about the identity, guys. Now there is some attributes are there over here. Now you can see there will be a K attribute will be there, K. Now when you are giving 0 over here, so it will be getting it exactly at the diagonal over here. Diagonal. Now here I will give it as 4, 4, 4. Or 5, 5, 5. So you will be getting it at diagonal place. Can you see this diagonal place? So if I give it K is equals to 0, is the same. You will be getting the same. Sorry, it is 0. Something like this. If I give it 1 over here, it will take 1 level up. It went on 1 level up once. So if I give it 2, it will go one level. Okay guys, now if I want it down, so I will give it as -1. Give it -1, you will be getting down here. You can play with the things whatever you want. Now let's move on with the next one, guys. What is the next one we have? Numerical. Huh? Arrange numerical format, right? Okay. Now let me give it, guys. Now I will give it as A1 is equals to np.arange. Now it will take 3 parts, right? What is the start, stop, and step? Now which one is mandatory? What is mandatory? Stop is mandatory. If you give one value, this will be the stopping point. What is the starting point? 0. Remember that. And step 1. Take it as 1 over here. Okay. Now if you give that, like I wanted 2 to 20 with step is equals to 3, means every third value it will be printing from 2, or it will skip 2 values. So you will be getting it 2, 5, 8, 11, something like this. Okay guys, so this is, now you can play with it like however. Now if I am giving it something like this, 30 to 10, then what I am going to get it? Huh? Empty. Error. Will not get an error. You will get an empty. Why? Step is positive means what? Starting value should be greater than the ending value. Okay. Now np.arange, and I am going to give it like 10 and 20 here. Can I give it like this? Yes, the decimal you can give it over here. In the range you can't give it over here. Here you can give the decimal. Whatever the decimal you want it, you can give it over here. You can give anything as a decimal in this 3. No problem about that. And you can also play with the negative value. What is the output? Empty. Why? Again, the starting is less than the ending over here. So now in this case, then we have to get it like 20 comma 4 like maybe around 1 minus 1, then you will be getting an output. What's the problem? Okay, clear guys? Now you can do the things. We have done it enough in the earlier, so you can play with the things. Now there is something called as Lin Space. Now Lin Space, what it will do is like it will take the starting value and ending value, and whatever the number you want it, it will divide that. It will extract so many values from the starting and the ending value. Now np.linspace. Now if you check it out, the syntax over here, can you see this? The syntax over here. Start, stop, and num. Okay, num is by default 50 values. Now whatever you are giving start value and the stop value, if you are not giving the number of values, then by default it will extract the 50 values from it. Okay, now endpoint, it will show you the endpoint. What is the endpoint? And red step, this is like what is the intervals. It will tell us the what is the intervals over there. Okay, access. Access we are going to talk about. I missed out the access. I would have talked over there itself. Now what is this? Start. I'm giving it 1 and 2 and I'm not giving anything. Still I will get the 50 values. And all these 50 values are in which dimension? One dimension it is. Huh? One dimension? Dimension only. Here one square only. Can you see this? See, they are arranged, they are looking like that 2-dimension rows and columns, but it is 1 dimension only. Now by default you will be getting it like, you know, like 50 over here. Now you want more or less, you can play with it. Like 1, 2, I want 1000 over here. Then you will be getting the 1000. Okay. Now if I give it a red step over here, red step is equals to true, I will give it. So I will get it the last, you will be getting the interval. See, this is the interval. Okay. This is the interval over here. Clear, guys? Red step. Now, if I say that endpoint is equals to false, the endpoint only, right? The other one, endpoint here. Now, if you check it out, the endpoint here, endpoint is true. That is, it is giving us the ending value. I don't want the ending value. Then I have to make it as a false over here. I didn't save it in any array, guys. You can save it and you can play with it if you want it. Now, these are the different ways of creating the okay, like this. You can do it. Clear, guys? Now, next one is, what's the next one? Random, right? Numerical, diagonal way, homogeneous, everything is finished. We are playing with a random. Random, we are having like 3 ways we can do it. Okay, now let's do this. np.random.rand. I said that this will take the shape and it will give you the randomly generated values, positive values, that is also floating point values. If I am giving it 6 over here, you are going to get the 6 values. Okay. No, I wanted 2-dimension random.rand and I will give it 4, 6. You will get it like this. It is here. Let me make it as a 5. Then it looks much better. See this, there is no negative value. All are floats. Okay. Now you can rand int. You can give it 2, 4, 5. What is the dimension here? 3-dimension. Now you can play with like random.np.random.rand n. What it will do? It will give the combination of positive and negative numbers. Okay, like this. Now I will give it as np.random.rand n. I will give it 4, 5. You will get it positive and negative values. Now np.random.rand n, 3-dimension. Okay. Now the most important is random.rand int. Now this will give us the option of both your desired number range as well as the shape. I want to start with 10 and I want to give it until 50. Now my shape I wanted 4, 6. This will give you all integers only, not decimals. Now you see this, you can play with the things. Now next one, you can give it the 3-dimension also. Give it 2, 4, 6. Okay. Now in this, see, first what we were having, only choice of giving us the shape. The numbers were 1 or 0. Then we got the number range, we give it. The shape, we don't have the choice. Shape, we don't have the choice. That is, you know, A range. A range is the one where we don't have the choice of the shape. A range and Lin Space. We are getting everything in the one dimension. Now, I want to, here in this case, the first case, the rand and n, you are getting a random value, not a homogeneous value. At least you are getting a betterment over here. Random values is generating. But in this, you have both. This is much more flexible. You can give the number range and also you give the shape over here. But here, you don't have the choice which number should be appearing more number of times. That you don't have it. Okay. So what we will have it is, we have a choice of that. Choice. Yes, there is a function called as choice, will provide us the choice which number should appear more number of times in this. Now, for example, I am having a list of numbers over here, or L1 is equals to. I kept it as like maybe I'm having these three numbers. Okay, let me take it as 1, 1 and 200 and 3, 3, 3. These are the three numbers I want to. I want to create a array with these three numbers, but I want 200 should be appearing more times. I don't have that choice anywhere in this. I can't control how many times it is happening. So what I can do it is, there is something called as choice, np.random.choice. I think so. Yes, it is there. So in this, the first one is the data. Okay, the first one is the data. Second one is the size, shape, how you want it. This is the one which you have to give it like which way you want it. There will be a P option will be there here. P is the one like how much percentage, which value should come up over here. Now I will show you how it will be coming up. Now first one is the data. That is, what is my data? L1 is my data. Shape is 4,6. Okay, 4,6. If I give it P, I'm not giving the P. I got it like randomly, I got it. Now, which one I'm going to get it, I don't know. Okay. Now, I can't have a control on this numbers. Now, I want to control it. P is equals to, now I will give it as, what is the percentage? What is the percentage you want? How many values are there? 3 values are there here. First one is, I wanted only 10%. 10%, that is 0.10, right? 10 divided by 100 is 0.10 only, 10. Okay. Next one, I wanted like around 30%. That is okay. Next one is 200, right? I wanted 200 as 60%, 0.6. Okay, 60 or something. Now, next one is 0. How much is left out in 100? 70 is finished. Only 30 is left out, 0.3. Okay, now let's see this. It should work for us. Can you see this? The 200 will be appearing more times. Okay, now if I run it, okay, a bit changed over here. I will make this one as 20 and this one I will make it as 50 and this one I will make it as 30. Now this one, let's make it 1 and this I will make it as 40. Now see this. Now 333 is the least one which is appearing, only 2 times. Next is like more frequently, you can see the 200 over here all the time. Clear, guys? Now these are the different ways of creating the NumPy array. Tomorrow we are going to do the indexing part and we will do the slicing also. Okay, I will stop it over here, and there is one more is there. Why we have to consider the NumPy over the list. List is very powerful as we know it. We are still considering the NumPy over the list is, there are 3 major things are there. One is it will occupy less memory, very fast in execution. Third one is it is very convenient. NumPy is very, very convenient. Tomorrow I will show you all those things. Okay. So then I will stop it and we will meet tomorrow. Thank you. Yeah, I will do it. But I missed out. Yesterday I was a bit busy. Yeah, yeah, I will provide you the project. No problem. I'm sorry, guys. I didn't see your messages. Anyhow, I will make sure tomorrow everything will be uploaded. Tonight I will upload everything for you. And I'm really sorry for that. The screen was blurred and I could not see it. Uh, I will try to frequently. I will look at the messages. Sorry for that. Thank you, guys. I'm ending the class.